Another very useful algorithm for classification is the k-nearest neighbor, or KNN. So let's look at how it works. It's a very simple algorithm. So imagine that you have these three classes again, the gastropod, bivalve, and quartz, in a feature space. Here I'm representing theta 1 and theta 2 as two different features, but of course you can have n dimensions, so many more features than just these two. So the principle of k-nearest neighbor is simply, if you take an unknown sample, which is represented by that question mark, you look at the k-nearest neighbor in that feature space to that particular sample. So let's say we take a k equals to 3, you look at the 3 nearest samples. And then, based on the distance of these samples, you look at how many samples of one class are closest to your particular unknown sample. In this case, we see that 2 samples are belonging to the quartz class and are actually closer. So, by conclusion, we reach the decision that this particular sample must be a quartz sample. Of course, you're not limited to k equal 3, you can go to much higher numbers, but that's one hyperparameter of the KNN algorithm that is very important, because the number of samples that you compare your unknown to will or might change your classification. So let's imagine, for instance, that we take a k equal 5. All of a sudden we have more samples from the bivalve class that are actually close to our sample. We still have 3 samples of the quartz class, so the vote would still be for the quartz class, but you can see that now it's essentially 3/5 of the voting goes for the quartz class, whereas before it was 2/3 of the voting going for the quartz class. And you can understand with this simple example of KNN that you could be in a situation where changing k changes the classification of your particular unknown. The other thing to know about KNN is that it is quite memory intensive, because the dataset is not learned. You don't learn feature from the dataset. The dataset is essentially in memory, and your sample will be compared to all the other samples in that dataset. Now that's great when the dataset is small, but if you have a very large dataset of millions and millions of data points, then that becomes a very impractical algorithm to use. And finally, KNN is quite sensitive to standardization and normalization, because that changes the distance. So if you do not standardize your data, then all of a sudden some of the features will be very far away, whereas other features will be much closer, and that could cause a lot of problem for KNN.